This video is for my 7th graders. So if you are an 8th grader watching this video, you are watching the wrong video. So 8th grade, your video will be entitled Molecules, and this is heat and temperature for 7th grade. 7th graders, we went over kinetic and potential energy in the classroom. You guys built your roller coasters. I was so proud of them. You guys put a lot of work into those. They looked excellent. I know, Friday was a little crazy, our last day of school, and we didn't get to test a couple of them. But I was really proud of your work. And even the 8th graders, when they saw your roller coasters, they were like, wow, they did so much better than we did. And theirs are really cool. And, I was really proud of the work you guys did. So now that we're done with kinetic and potential energy, we're going to move on to heat and temperature. So for this week, your assignments will be on Discovery Education. So remember, discoveryeducation.com, your username or your login is your Weavis, and your password is FPK820, and I'm going to send that in a live grades attachment for you. So you'll see a folder that says heat and temperature, 7th grade. You'll click on that folder. All of your work will be in there, just like we did at school. So this work is for about 2 weeks. You can submit it all on Friday if you want, or you can submit the daily tasks as you complete them. So it's up to you, however you wish to do this. I know some kids wait a couple days and send the work at once. I know some people want to send it every day. So it's just really whatever works for you. That's kind of the beauty of online learning. So with heat and temperature, task 1 is going to be read your chapter, watch your videos. As you know, Discovery Ed has your videos for you to watch. Fill out your guided notes. So I'm going to attach your guided notes in live grades. So you can write them down on a piece of paper if you want and take a picture of your notes and send them to me on live grades, or you can leave the notes on the screen if you don't have a printer and just write down what you would write down in the blanks and send that to me. But either way, while you're reading your chapter, you need to do your guided notes. So that is your first assignment. There are a lot of videos in this chapter, and it is really long. So your book will let me know if you watched your videos or not, and they are very interesting. The one that I want you to watch is the Super Fridge at Lancaster, England. It's about science. It's only 1 minute and 38 seconds, but scientists in Lancaster, England are studying the strange behavior exhibited by matter at temperatures close to absolute zero. You'll learn while you're reading that scientists have tried to get to absolute zero. So what this is it's not 0 degrees Fahrenheit like we would think. Absolute zero. So let me give you a little background. Matter, as you know, is everything around us. Matter makes up everything in the world. Even in solids, those atoms are slightly vibrating back and forth. They don't move around freely like they would in a gas, or they don't flow like they would in a liquid, but they are still moving a little bit. And they have kinetic energy, because we learned that kinetic energy is the energy of movement. So at absolute zero, scientists theorize that those atoms will stop moving. And so scientists try to get there where there is no movement. They want to kind of see what happens. Like, oh, what's going to happen if we stop the matter from moving? So this is an interesting video. It's talking about, scientists on that quest. Like I said, it's only 1 minute and 38 seconds. So I want to make sure you watch that. It is assigned to you. There's another video talking about heat being everywhere. It's 1 minute and 58 seconds long. um, scientists are going around with thermograms, or and they are looking at the hot spots and kind of showing you heat is everywhere. We don't really think of everything as having heat energy, but they kind of show you everything kind of has a little bit of heat energy, and they show you that with the camera. So I really want you to see and watch that video as well. So real quick, what I want you to do, we talk about heat, we talk about temperature, and in everyday words, we kind of use them interchangeably. We're like, oh, it's, this is so hot, or this temperature, or this has this much heat. We kind of don't distinguish the difference in our everyday language. But in science, they have very precise meanings. So real quick, just think of this like your bell ringer. Write down some ideas of what you think heat is and what you think temperature is. Are they the same? Are they completely different? Are they similar? So just take a second, pause this video, and write down what you think heat and temperature really means. So I'll give you a second to do that real quick. Okay, so you should have paused the video, and hopefully I'll get better at these as time goes on. 7th graders, you weren't around the last 2 years when we made documentaries. The 8th graders were, but we have made several film documentaries in the last couple years, and you can ask those students. I'm always the most nervous one on camera and filming. It's just something I'm not meant to be an actor, so I get really nervous on camera. So hopefully these will get a little better as time goes on. So in science, a fireplace, if you're burning some wood and a candle that you light, they might have the same temperature. They might burn at the same temperature, believe it or not. But the heat that is given off from the fireplace is much greater than the heat given off from the candle. So that's kind of the difference, is things might burn at the same temperature. I told my 8th graders, when we were talking about matter, what is the boiling point different for a drop of water, or is it the same for a drop of water and a swimming pool? And they kind of said it's different, but the temperature at which water boils is the same for a swimming pool as it is for a drop of water. It just takes longer for the swimming pool to get to that temperature. So temperature is different from heat in that way. So you'll learn about that in your chapter. Another thing that you'll learn in your chapter is the particle model of matter. So scientists actually developed this when they were trying to study gas, but then they realized, oh, well, this applies to solid, liquid, and gas. So now it is called the particle model of matter, not just of gas. And it discusses how changes in the states of matter occur with variations in temperature and pressure. So you'll learn about that. When you add or remove temperature from matter, it can change state. So you'll learn about that in your book. Then you'll learn about chemical bonds as you're reading. They are formed when 2 or more atoms are combined together. So if you have, carbon and oxygen, they'll bond chemically. So that is that chemical bond between carbon atom and an oxygen atom stores chemical energy. So they do this. A lot of kids just think that these atoms just stick together, but they don't. what happens is they are sharing electrons. So your 3 subatomic particles, as you remember, I want you to think about them real quick. Pause the video, write those down, your 3 subatomic particles, and then I'll let you know what they are. So go ahead and think about that. Need like Jeopardy music. So your 3 subatomic particles are protons, neutrons, and electrons. So the protons and neutrons, if you remember, they're in the nucleus of the atom, okay? The nucleus always has a positive charge because neutrons are neutral, they have no charge. Protons have a positive charge. So remember that P for proton is positive and N for neutron is neutral or no charge. So your electrons are negatively charged and they are circulating around the nucleus of the atom. So whenever this carbon atom and oxygen atom come together, they are actually sharing electrons. They're like, hey, I need one, you've got an extra, we'll share these. And that's how they form that bond. So they don't actually just stick together and just, stick. They actually are sharing those electrons, and that's how those chemical bonds are made. So you'll learn a little bit about that in your book. Let me find, I'm actually looking at your book right now. So there's a video about energy and the 4 states of matter. It's 3 minutes long. It tells you about, we study solid, liquid, and gas, but there is a 4th state, plasma, and this video talks about the matter and how it moves and how the particles move in those 4 states. So as you're watching that video, I need you to write down that particle motion for those 4 states. You'll take a picture of that and you'll send that in as well, okay, on lab grades. If you want to, you can type it on Word and send it in. Some kids prefer to write it on paper and take a picture of it and send it in to me. Some kids would rather write it on a Word document and send it in. Really, whatever is easier for you. So be sure to watch that video. Whenever you're going through your chapter, like I said, it's a long chapter. I will send you your notes. I have, my copy of the notes here. These are just the guided notes that we always do to help you learn this chapter. So I will send you that. So it might take you a day or 2 to get through this chapter. It'd probably take us 2 days at the school. So the next section is what are thermal energy, heat, and temperature, and what's the difference between them. So this is a really important section of your chapter. It says according to the particle model of matter, it says that all matter is made up of tiny particles called atoms and molecules. So an atom is a single element from the periodic table. I'm going to email you a periodic table, and you can download it. You can easily Google one as well. It's really easy. There's some great ones on Google. They're color coded. They really help you learn the periodic table. So this movement of those atoms provides you with thermal energy, okay? Heat is the transfer of this thermal energy, okay? Temperature is a measure of the average kinetic energy of the particles, okay? So you may remember our kinetic energy equation. I'll let you think for a second about that. That was our favorite equation that we worked on the board several times for practice. We did the bell ringers on it. Remember, Ke is equal to 1/2 the mass times the velocity squared. Okay, so that was that equation we used a lot. So the temperature is a measure of the average kinetic energy, okay? So it kind of like sums all that energy up and averages it out just like you would in math class, okay? So there is a range of kinetic energy, but temperature is that average, okay? So some will be moving slower, some will be moving faster, but you know, it kind of measures right there in the middle. So actually thermal energy is considered a property of matter. It is a property that we can measure. It is an extensive property of matter, so it actually changes with how much stuff there is. So like I said, boiling point is not extensive, okay? That temperature is the same for a drop or a gallon. Or a gallon or a pool or whatever. But extensive properties, they actually change with the amount of matter, and temperature is one of those that changes, okay? Because if you burn a piece of paper versus you have a huge bonfire, right, the temperature or the radiant heat given off from those is going to be different. So those are extensive properties of matter that change with how much stuff there is. So color, which is a property of matter, density, pressure, melting point, boiling point, those are considered intensive. So those do not change with how much, okay? It just might take longer to reach that temperature when there is a lot of it, but it does not, that temperature is the same, okay? So be sure to read through that part of your book. There's another video that you need to watch called The Movement of Heat. So it talks about heat energy can be transferred in 3 ways: conduction, convection, and radiation, okay? So you need to know the difference between those 3. So as you're watching the video, you know, jot down, type in Word, the difference between those 3 and then how they're related for me and send that in. So like I said, this is a long chapter. You know, this would take us a couple days in class to do, so don't think, oh my gosh, I have to do all this today. We would read through this, we would do our notes, we would watch our videos, we would have these discussions over a couple of days. So don't feel like, you know, don't get overwhelmed and think you have to do all this in one day or in one sitting, okay? So it says, what is the process for developing potential design solutions? So this talks about engineering and what engineers do. Engineers are often finding solutions to problems. So they kind of have this open-ended question, you know, where they kind of brainstorm and they kind of think together, a group of individuals, and then they focus on the solution, like how are we going to get here? All right, they know that they need to solve this problem. This is the problem, and they're like, okay, so how do we get to solving this? So this kind of talks about engineering design, and then the scientific method. Okay, so there's a video called The Scientific Method at the end. It talks about the 6 steps of the design process. And how engineers do that. This also talks about the Wright brothers and how they got to design an aircraft, or got the first working aircraft with the scientific method. So as you watch that video, be sure that you write down the 6 steps of the scientific method and write down how the Wright brothers, each step, how they applied that to building their first aircraft. And like I said, in class, we would have these discussions. You know, if you want to record it like I am and send it in to me and have your discussion, that's fine too. You know, if that would be easier for you, you can write them down, you can type them, or you can actually film yourself having a discussion if you would like. So that's up to you. So this video is just about your first task, okay? I'll make another one talking about your other tasks. Feel free to watch this as many times as you need. Like I said, I will send your notes. I will attach everything that you need in Live Grades. So Live Grades is going to have your instructions as to how you, well, describing the assignments, reminding you how to get the Discovery Ed, and then what you need to do once you're there. You will submit everything on LiveGrades unless I specify that this can be submitted on Discovery Ed. Some things can, some things cannot. So if you want to submit it on everything on LiveGrades, that's fine. If I tell you to submit it on Discovery Ed, feel free to do it that way. It's a little easier for me to track everything that way on Discovery Ed, because I can keep you bunched into your different classrooms that way. So if you have any questions, email me. Stay safe. I miss you guys. And, you know, I don't know when we'll be back to school, but every week that we're out, you can expect these videos, okay? So, again, don't hesitate to contact me if you need anything. Thanks.